Good morning to one and all. I am Dr.S.THAIYALNAYAKI, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Operating system. Here we see about the introduction of operating system. Operating systems in simple words. An operating system is the most important software that runs on a computer. It manages the computer's memory and process as well as all of its software and hardware. It also allows you to communicate with the computer without knowing how to speak the computer's language. The operating system manages all of the software and hardware on the computer. It performs basic tasks such as file, memory and process management, handling input and output, and controlling peripheral devices such as disk drive and printers. Examples of operating system. Some examples of operating systems include Apple Mac OS, Microsoft Windows, Google Android OS, Linux operating system, and Apple iOS. Apple Mac OS is found on Apple personal computers such as the Apple MacBook, Apple MacBook Pro, and Apple MacBook. Then we have one doubt about what is my operating system in our computer. Go to the settings app on your mobile device, tap about phone or about device, check Android version. Then we know about who is the mother of the operating system. Unix is the mother of all modern operating systems. Nowadays, which OS is used in school? I am pretty sure most schools are running on Windows as their primary operating system. I think Windows 10. Another doubt in our mind, as we write our own operating system. Writing an operating system from scratch requires a strong command of computer science, a programming language like C or C++, assembly language, and code management practices. Next, who invented the operating system? The first operating system sold along with computer was invented by IBM in 1964 to operate its mainframe computer. Another doubt one is who is the father of our operating system? Gary Kidal, and the 14th anniversary of the birth of PC operating systems. Next, which operating system is mostly used in world? Microsoft Windows is the mostly widely used computer operating system in the world, accounting for 64.27% share of the desktop, tablet, and console OS market in June 2023. What is an operating system? An operating system is the program that, after being initially loaded into the computer by a boot program, manage all of the other application programs in a computer. So, application programs make use of the operating system by making requests for service through a defined application programmable interface, that is API. In addition, users can interact directly with the operating system through a user interface such as an command line interface CLI or a GUI, graphical user interface. Next, why use an operating system? An operating system brings powerful benefits to computer software and software development. Without an operating system, every application would need to include its own UI as well as the comprehensive code needed to handle all low-level functionality of the underlying computer, such as disk storage, network interfaces, and so on. Instead, many common tasks such as sending a network packet or displaying text on a standard output device such as display, it can be offloaded to system software that serves as an intermediary between the applications and the hardware. So, the system software provides a steady and repeatable way for applications to interact with the hardware without the applications needing to know any details about the hardware. As long as each application accesses the same resources and services in the same way, that system software, the operating system, can service almost any number of applications. This vastly reduces the amount of time and coding required to develop and debug an application, while ensuring that users can control, configure, and manage the system hardware through a common and well understood interface. Once installed the operating system, it relies on a vast library of device drivers to tailor operating system services to the specific hardware environment. Thus, every application may make a common call to a storage device, but the operating system receives that call and uses the corresponding driver to translate the call into actions. Actions means commands needed for the underlying hardware on that specific computer. Today, the operating system provides a comprehensive platform that identifies, configure and manage a range of hardware including processor, memory device and memory management, chipsets, storage, networking, port communication such as video graphics array VGA and high definition multimedia interface HDMI and universal serial bus USB and subsystem interfaces such as peripheral component interconnect express PCIe. Next, what are the functions of an operating system? An operating system provides three essential capabilities. It offers an UI through CLI or guide tools. It launches and manages the application execution and it identifies and exposes system hardware resources to those applications, typically through a standardized API. Next, UI, user interface. Every operating system requires a UI, enabling users and administrators to interact with the operating system in order to set up, configure and even troubleshoot the operating system and its underlying hardware. There are two primary types of UI available. One is CLI and another one is GUI. The CLI or terminal mode window. It provides a text-based interface where users rely on the traditional keyboard to enter specific commands, parameters and arguments related to specific tasks. Another one is GUI, graphical user interface or desktop. It provides a visual interface based on icons and symbols where users rely on gestures delivered by human interface devices such as touchpad, touch screens and mouse devices. The GUI is mostly frequently used by casual or end user that are primarily interested in manipulating files and applications, such as double clicking a file icon to open the file in its default application. The CLI remains popular among advanced users and system administrators that most handle a series of highly granular and repetitive commands on a regular basis, such as creating and running scripts to set up new personal computer PCs for employees. First one is application management. An operating system handles the launch and management of every application. This typically supports an array of behaviors including time sharing multiple processes or threads so that various tasks can share the available process timing. Handling interruptions that applications provide to gain a processor immediate attention, ensuring there is enough memory to execute the application and its corresponding data without interfering with other processes. Carrying out error handling that can gracefully remove an application's process and performing memory management without disrupting other applications or the operating system. An operating system can also support APIs that enable application to utilize OS and hardware functions without the need to know anything about the low-level OS or hardware stage. As an example, an Windows API can enable a program to obtain input from a keyboard or mouse, create GUI elements such as dialog windows and buttons, read and write files to a storage device and more, etc. Applications are almost always tailored to use the operating system on which the application intends to run. Additionally, an operating system can perform the following services for applications. In a multitasking operating system where multiple programs can be running at the same time, the operating system determines which application should run in what order and how much time should be allowed for each application before giving another application a turn. It handles input or output to and from attached hardware devices such as hard disk, printers and dial-up ports. It sends messages to each application or interactive user or to a system operator about the status of operation and any errors that may have occurred. It can offload the management of batch job, for example, printing, so that the initiating application is freed from this work. On computers that can provide parallel processing, an operating system can manage how to divide the program so that it runs on more than one processor at a time. All major computer platforms, hardware and software require and sometimes include an operating system. An operating system must be developed with different features to meet the specific needs of various form factors. Next, second one is device management. An operating system is responsible for identifying, configuring and providing applications with a common access to underlying computer hardware devices. As the operating system recognizes and identifies hardware, the OS will install corresponding device drivers that enable the OS and applications running on the OS to use the device without any specific knowledge of the hardware or devices. An operating system is responsible for identifying the correct printer and installing the appropriate printer driver so that an application needs to only make calls to the printer without having to use codes or commands that are specific to that printer. That is the operating system's job. The situation is similar for other devices such as USB ports, networking ports, graphic devices such as GPUs, graphics processing units, motherboards, chipsets and storage device such as serial attached SCSI, SAS disk, adapter and a disk that are formatted with a suitable file system. The OS identifies and configures physical and logical devices for service and typically records them in a standardized structure such as Windows registry. Next one is functions of operating system. Here we have nearly 15 functions of OS. Here we see that. First one is resource management. In resource management, the operating system manages and allocates memory, CPU time and other hardware resources among the various programs and processes running on the computer. And then process management. The operating system is responsible for starting, stopping and managing processes and programs. It also controls the scheduling of processes and allocates resources to them. And another one is memory management. The operating system manages the computer's primary memory and provides mechanisms for optimizing memory usage. Another one is security. The operating system provides a secure environment for the user, applications and data by implementing security policies and mechanisms such as access controls and encryptions. And next one is job accounting. It keeps track of time and resources used by various jobs or users. And next one is file management. The operating system is responsible for organizing and managing the file system, including the creation, deletion and manipulation of files and directories. And next one is the device management. The operating system manages input-output devices, that is printer, keyboard, mice and displays, etc. It provides the necessary drivers and interfaces to enable communication between the devices and the computer. Next one is networking. The operating system provides networking capabilities such as establishing and managing network connections, handling network protocols and sharing resources such as printers and files over a network. And another one is user interface. The operating system provides a user interface that enables users to interact with the computer system. This can be graphical user interface GUI, a command line interface CLI or a combination of both. Next one is backup and recovery. The operating system provides mechanism for backing up data and recovering it in case of system failures, errors or disasters. Another one is virtualization. The operating system provides virtualization capabilities that allow multiple operating systems or applications to run on a single physical machine. This can enable efficient use of resources and flexibility in managing workloads. And next one is performance monitoring. The operating system provides tools for monitoring and optimizing system performance, including identifying bottlenecks, optimizing resource usage, and analyzing system logs and metrics. And next one is time sharing. The operating system enables multiple users to share a computer system and its resources simultaneously by providing time sharing mechanism that allocate resources fairly and efficiently. And next one is system calls. The operating system provides a set of system calls that enable applications to interact with the operating system and access its resources. System calls provide a standardized interface between applications and the operating systems, enabling portability and compatibility across different hardware and software platforms. And last one is error detecting aids. These contain methods that include the production of dump, traces, error messages and other debugging and error detecting codes. Next, objectives of operating system. Let us now see some of the objectives of the operating system which are mentioned below. First one is convenient to use. One of the objectives is to make the computer system more convenient to use in an efficient manner, and another one is user friendly. To make the computer system more interactive with a more convenient interface for the user. And another one is easy access. To provide easy access to users for using resources by acting as an intermediary between the hardware and its users. And then another one is management of resource. For managing the resource of a computer in a better and a faster way. And last one is controls and monitoring. By keeping track of who is using which resource, granting resource requests and mediating conflicting requests from different programs and users. And another one is fair sharing of resources, providing efficient and fair sharing of resources between the user and the program. These are all the objectives of the operating system. Next, types of operating system. Nearly we have 10 types of operating systems. Just here we see about what is what, elaborately we see later. First one is batch operating system. A batch operating system is a type of operating system that does not interact with the computer directly. There is an operator who takes similar jobs having the same requirements and groups them into batches. And then second one is time sharing operating system. In this time sharing operating system, it's a type of operating system that allows many users to share computer resources, maximum utilization of the resources. And then third one is distributed operating system. In this type of operating system that manage a group of different computers and makes appears to be a single computer. These operating systems are designed to operate on a network of computers. They allow multiple users to access shared resources and communicate with each other over the network. Example, it includes Microsoft Windows Server and various distributions of Linux designed for server. Another type is network operating system. Network operating system is a type of operating system that runs on a server and provides the capability to manage data, users, groups, security, applications and other networking functions. Another one is real-time operating system. In this type of operating system that serves a real-time system and the time interval required to process and respond to inputs is very small. In this operating system, it is designed to respond to events in real time. They are used in applications that require quick and deterministic response such as embedded system, industrial control system and robotics, etc. And next type is multiprocessing operating system. Multiprocessor operating system used in to boost the performance of multiple CPUs within a single computer system. Multiple CPUs are linked together so that a job can be divided and executed more quickly. Next type is single user operating system. Single user operating system are designed to support a single user at a time. Example, Microsoft Windows for personal computer and Apple Mac OS. Another type is multi-user operating system. Multi-user operating system are designed to support multiple users simultaneously. Examples include Linux and Unix. Next type is embedded operating system. In this type, it is designed to run on device with limited resources such as smartphones, wearable devices and household appliances, etc. Example, Google's Android and Apple iOS. Next type is cluster operating system. In this operating system designed to run a group of computers or a cluster or to work together in a single system. They are used for high performance computing and for applications that require high availability and reliability. Examples are ROX cluster distribution and OpenMPI. These are some of the types of operating system. Here we see just what is what. Next, how to check the operating system. If you want to purchase new operating system means, we check following factors. It will be useful for you in future. There are so many factors to be considered while choosing the best operating system for our use. These factors are mentioned below. First one is price factor. Price is one of the factors to choose the correct operating system, as there are some operating systems that are free like Linux, but there is some more operating system that is paid like Windows and Mac OS. And then second one is accessibility factor. Some operating systems are easy to use like Mac OS and iOS, but some OS are a little bit complex to understand like Linux. So you must choose the operating system in which you are more accessible. And then another one is compatibility factor. Some operating systems support very less applications, whereas some operating system supports more applications. You must choose the OS which supports the applications which are required by you. And the last one is security factor. The security factor is also a factor in choosing the correct OS, as Mac OS provides some additional security, while Windows has the little fewer security features. Next one is examples for operating system. Windows. In Windows, GUI based used in PCs. Another one is GNU or Linux. It will be used in personal computer, workstations, ISP, file and printer server, 3-tier client server, etc. And third one is Mac OS. It's nothing but Macintosh. It is used for Apple's personal computers and workstations. Workstations means MacBook and iMac. Another one is Android. It is used in Google's operating system for smartphones, tablets, smartwatches, etc. And last one is iOS. Apple's operating system for iPhone, iPad and iPad Touch. Next, how will you install operating system in our system or mobile anything? Some steps are here. The steps for installing an operating system like Linux, Microsoft Windows, depending on the operating system version you are installing. Each version has different steps, requirements and options that are unique to that operating system. Also, each operating system has different requirements for your computer to be able to run correctly. First step to purchasing the operating system. First, you need to purchase the operating system that you want to install on the computer. The best place to purchase the operating system from is a retail store like Best Buy or through an online store like Amazon, Newegg, etc. The operating system may come on multiple CDs, that is compact disc or DVD, digital versatile disc, or it may even come on a USB, universal serial bus, flash drive, etc. Downloading a copy of the operating system is usually the most convenient way to obtain it. However, be sure you obtain the operating system from the publisher like Microsoft. Downloading it from another source may result in an unusable or illegal copy of the software. And then second step to install the operating system is to install the computer's operating system using a CD or DVD. You need to configure your computer to boot from the CD or DVD drive. You can change the boot sequence in your BIOS setup and setting the CD or DVD drive to be the first boot device. Some computers may also allow you to access the boot sequence directly at computer startup without entering the BIOS by pressing a specific key on the keyboard. The key to press differs from each computer but is often the delete key or one of the function keys. And how to enter and exit the BIOS or CMOS setup during installation of OS operating system. If the operating system software came on the USB flash drive, you need to configure the computer to boot to a USB device as the first boot device. Once the computer is configured to boot to the proper device, the computer should load the operating system installation program and guide you through the install process. You will be asked questions along the way for configuration of basic settings like date and time, user account name, and if you want to enable automatic operating system updates. Go through the installation steps, answering questions and selecting the preferred options. And third step, how to run the operating system. After the operating system has been installed, the computer should load into the operating system. You may then proceed with the installing software that you want to the computer and updating any settings you want. Next, why do we install operating system in our computer? An operating system is the most important software that runs on a computer. It manages the computer's memory and process as well as all of its software and hardware. So it allows you to communicate with the computer without knowing how to speak the computer language. So concept of OS as after being initially loaded into the computer by a boot program, it manages all of the other application programs in a computer. Here we see about the three main uses of operating system, three main functions. First one is manage the computer resources such as central processing unit, memory, disk drive, printer. This is the first main function of OS. And second one is establish a user interface, UI. And third one is execute and provide services for application software. This is the three main functions in operating system. And then two main function of operating system is that is to interact with the hardware and to interact with the user. This is the two main functions in OS. Next we see about the evaluation of operating system. Operating system have evolved in past years. It went through several changes before getting its original form. These changes in the operating system are known as the evaluation of operating system. So OS improved itself with the invention of new technology. Basically, OS added the feature of new technology and making itself more powerful. Let us here we see about the evaluation of operating system year-wise. First of all, no OS, zeros to 1940s. In that period, that is before 1940s, there was no use of OS, operating system. Earlier people are lacking of operating system in their computer system. So they had to manually type instructions for each task in machine language, 0 or 1, it based on the language. And at that time, it was very hard for user to implement even a simple task. And it was very time consuming and also not user friendly because not everyone had that much level of understanding to understand the machine language, matching the language, and it required a deep understanding. And the second period will be 1940s to 1950s, it's a batch processing system. With the growth of time, batch processing system came into the market. Now users had facility to write their programs on punch cards and load it to the computer operator. And then operator make different batches of similar types of jobs and then serve the different batch, that is group of jobs, one by one to the CPU. CPU first executes jobs of one batch and then jump to the other batch one by one, see in sequence manner. And then third period is 1950s to 1960s, it's a multi-programming systems period. Multi-programming was the first operating system where actual revolution began. It provided user facility to load the multiple program into the memory and provide a specific portion of memory to each program. When one program is waiting for any input-output operations which take much time. At that time, the OS give permission to CPU to switch from previous program to other program, that is which is first in ready queue for continuous execution of program with the interrupt. And the next period is 1960s to 1970s. It's a time sharing system period. Time sharing systems is the extended version of multi-programming system. Here one extra feature was added to avoid the use of CPU for a long time by any single program and give access of CPU to every program after a certain interval of time. Basically, OS switches from one program to another program after a certain interval of time so that every program can get access of CPU and complete that work. And then another next period is 1970s to 1980s. It's the introduction of GUI, graphical user interface. With the growth of time, GUIs came. First time OS become more user friendly and changed the way of people to interact with computer. GUI provides computer system visual elements which made users interaction with the computer more comfortable and user friendly. User can just click on visual elements rather than typing commands. Here are some features of GUIs in Microsoft Windows, icons, menus, windows, etc. And the next period is 1980s to 1990s. It's a networked system period. At 1980s, the craze of computer networks at its peak, a special type of operating system needed to manage the network communication. So the OS like Novel Network and Windows NT were developed to manage network communication, which provide users facility to work in collaborative environment and made file sharing and remote access very easy. And the next type is mobile operating system. In this period is late 1990s to early 2000s. Invention of smartphones create a big revolution in software industry. To handle the operation of smartphones, a special type of operating systems were developed. Some of them are iOS and Android, etc. These operating systems were optimized with the time and become more powerful. And next one is distributed operating system. Here it provides an environment in which multiple independent CPU or processor communicates with each other through physically separate computational nodes. Each node contains specific software that communicates with the global aggregate operating system. In this case, the programmer or developer can easily access any OS and resource to execute the computational task and achieve a common goal. It is the extension of a network operating system that facilitates a high degree of connectivity to communicate with other users over the network. And next period is 2010s to ongoing. It's a AI integration period. With the growth of time, artificial intelligence came into a picture. Operating system integrates features of AI technology like Siri, Google Assistant and Alexa and become more powerful and efficient in many ways. These AI features with the operating system create a entire new feature like voice commands, predictive text and personalized recommendations. And then now we use embedded operating system also come here. Embedded operating system is the specific purpose operating system. It is used in computer systems embedded hardware configuration. In this OS, it is designed to work on dedicated devices like automated teller machines, ATMs, airplane systems, digital home assistants and the IoT, Internet of Things devices. Types of operating system. An operating system is a well-organized collection of programs that manage the computer hardware. It is a type of system software that is responsible for the smooth functioning of the computer system. Here we see about the just three types of operating system, that is batch OS, multi-programming and real-time OS. Batch operating system. In the 1970s, batch processing was very popular one. In this technique, similar types of jobs were batched together and executed in time. People were used to having a single computer which was called a mainframe. In batch operating system, access is given to more than one person. They submit their respective jobs to the system for the execution. The system put all of the jobs in a queue on the basis of first come, first serve basis and then executes the job one by one. The user collects their respective output when all the jobs get executed. The purpose of this operating system was mainly to transfer control from one job. Just here we see the advantages of real-time operating systems. Maximum consumption, maximum utilization of devices and systems. Thus more output from all the resources. And then one is task shifting. Time assigned for shifting task in these systems is very less. Example, older system it takes about 10 microseconds. Shifting one task to another task. In the latest system it takes 3 microseconds. And then focus on application. Focus on running applications and less importance to applications that are in the queue. Real-time OS in embedded system. Size of the program is small. It can also be embedded systems like a transport and others. Another one is error-free. These type of systems are error-free. And then memory allocation. Memory allocation is best managed in these types of systems. And then disadvantages of real-time operating systems. Limited task. Very few tasks run simultaneously and their concentration is very less on few applications to avoid errors. Use heavy system resources. Sometimes the system resources are not so good and they are expensive as well. And then complex algorithm. The algorithms are very complex and difficult for the designer to write on. And then device driver and interrupt signals. It needs specific device drivers and interrupt signals to respond earliest to interrupt. And then one is thread priority. It is not good to set thread priority as these systems are very less prone to switching tasks. Minimum switching. RTOS perform minimal task switching. These are all the disadvantages of real-time operating system. Here we see the comparison of regular operating system and real-time operating system. Regular operating system complex, real-time will be simple. It will, regular OS will be best effort. In real-time OS, it's a guaranteed response. Regular OS fairness, and real-time OS strict timing constraints, and regular OS average bandwidth. In real-time minimum and maximum limits, and regular OS unknown components. In real-time components are known. In regular unpredictable behavior, in real-time predictable behavior. In regular OS plug and play, in real-time OS, RTOS is unupgradable. Thank you.